exponents. So you see numbers like 2 to the second, 2 to the third. I'll change a bit, 16 to the 54th, or we'll be wild and do this. The 1, 0, let's add another 0, 0, 0. So 1 millionth power. What is this telling us? Well, this is nothing more than multiplication. So it's saying in a shorthand form, saying, multiply 2 by itself twice. Here it's saying multiply 2 by itself 3 times, 16 by itself, 54 times, and then 1081 by itself 1,000,000 times. So these go by multiple names. I hear people use power, call them powers. Some people may say indexes, but most of the time you're not going to have to worry about that. You just these are exponents. That's what a lot of people will use and say the phrase. So there's not much to this, except just knowing that when you see something like 5 to the 10th, you're multiplying this by itself 10 times. So this is just saying this is the number, and this is how many times you're going to multiply it over itself. So if we had like 6 to the third, well, we know we have to multiply 6, but how many times? 3 times. And so we're familiar with, this is the positive side of things. So if I say 5 to the 4th, this is actually like a plus 4. I know there are concepts using plus and minuses, but keep it pretty basic. 5 to the positive 4, right? So this equals 5 times 5 times 5 times 5. And remember, this is all multiplication, right? This is all multiplication. Now, what if I did something different? What if, instead of saying 5 to the 4th, I said 5 to the negative 4th. Well, if this, right, this is the positive exponent, this is the negative exponent. Well, if this is equal to multiplication, I don't know if I went over this, but dots are also used to mean multiply as well. Instead of doing it, so if this multiplication, what is this? Well, then this should be dividing by this number, 4 times. And in order to get that, right, we'll have to flip this. So 5 to the negative 4th is actually 5. It's actually 1/5 to the 4th power. So which actually means 1 5 1 times 5 1 times 5 1 times 5. Or you could always elongate it and do it this way. And so we've hit our first rule, which is we could say a to the negative n is equal to a to the n. But there's a lot of proof into this, which I won't get into. And so what we're doing is we're taking the reciprocal. You'll hear that term reciprocal, and what it just means is this right here is the reciprocal. I can't spell today. Reciprocal. Okay, and now there's a couple of special exceptions. Okay, well, and you know these but we haven't explicitly talked about it before. So what is 9? Or these whole numbers: 10, 11, 12, 13, 14, 15, right? Well, I already told you that, for example, 9 to the 2 is the same as multiplying it 9 2 times. Well, this 9 is the same as 9 to the 1. Why? Because if I multiply 9, just one time, I just get 9. Same thing. So 10 to the 1, so it's equal to 10. It's just by itself one time. Now, what if I say, what is 9 to the 0? Right? This is a little tricky, but just know that, it's just 1, right? Or what if I do 10 million to the 0 power? Well, that's just 1. So anything to the 0th power, and it's just a rule you'll have to memorize, is just 1. So, this is another rule. You could say a to the 0 is just 1. A being your constant. And the last thing we want to get into is, let's clear this. What if you get 0 to the 0th power? Well, that's just indeterminate. Right? So this is kind of when you start getting into graphing, or when you start trying to do higher level maths, you'll run into this often. But since this is beginner level, we don't need to worry about it. But just know that there's no real answer, because a lot of times the answer will be either 1 or 0, and so a lot of times people will just say indeterminate. And then that's all you need to really worry about it when it comes to that. So we know that there's a couple of exceptions. Not a couple of exceptions, but a couple of cases, which is a to the 1 first power is just a to the 0 is 1, and then a to the negative n is just 1 over n. It's just 1 over. See if I can fix this. A to the n. And so, these may seem like a lot, but if you do a lot of problems, this will come in, this will become second nature to you. Right? And then the last one, which I forgot to remember, is, the 0 to the 0 power. And this is just a special case. And usually we don't care too much about this. If you run into this, there are, books and stuff to look it up, but most of the time you're going to be floating here. This is very rare that you'll be floating here. You'll be floating in these areas right here. And remember when we were talking about BODMAS, right? We had brackets. So another thing to keep in mind is the brackets, right? Because now you'll see why this will be very, very important. Squared and then negative squared. So if I did this squared, this is saying, again, multiply -3 times -3, right? And so this would be, again, 9. But this, and some people will confuse this, that's why you have to have the brackets in there. So some people might think that this is the same as this, right? This will be equal to -3 times -3, which is 9. Well, that's incorrect, because that's why you need to put the brackets on. Now it becomes clear that, okay, first I need to solve for inside. So this is 3 times 3, right? And so this equals 9. So the answer is actually -9. So do you see the contrast between these, right? And the same thing will happen, if you were to do 3 squared times let's say 4 to the third times 2 with the exponent, right? So, I get a little bit ahead of myself. So this is 3 squared, times 4 to the 6th. Okay. So you want to keep attention to that, because then, what can also happen is, if I change this around, this is incorrect. So I need to actually multiply this 2 by this 2 and this 2 by this 3. So instead of getting that 3 squared times 4 to the 6, I'm actually getting 3 to the 4th times 4 to the 6th. So brackets become very, very important in your understanding right now when you're dealing with exponents. So that concludes this lesson. And in the next lesson, we'll be getting into the different types of roots, square roots, cube roots, all kinds of roots.